afternoon once again. You are all welcome to today's class, MTA 232, Elementary Differential Equation. And today we'll be talking about homogeneous equation and how do we represent homogeneous equation to solve the differential equation. So let's look at it. I can quickly share my screen. So can you see my screen, please?
Yes, sir.
Yeah, okay, good. I'm happy you can see my screen. So, like I told you, homogeneous equation. Or homogeneous method, let's call it method for now. Because it's a way of solving a particular problem. Okay. Let's f of x, kf of x, kf of x, ks, comma, ky equals to f of x, comma, y. Then we also let v equals to y over x. You will know why we are doing this. And if I say v equals to this, what is 1 over v? Anybody? V equals to y over x. What is 1 over v? So look at it. This is what we are saying. Say what? Is what?
X over
That's x. No, that's x over vy.
Don't forget we are saying 1 over v. I want to find inverse of this v. What will happen to this? It will be x over y. Do you agree with me?
Yes.
This is what I'm doing. Just a digression. If I said, if you cross multiply, you have vx equals to y, right?
Yes, sir.
And I need, what do I need to make this one 1 over v? Anybody? Anyway, don't worry. By the time we get there, you will see what I'm doing. Let's just continue. Y over v, then my y is equals to vx. Do you agree? Like I show you now, y equals to vx. So you can circle this one. Because it has a lot to do with what we are doing. So now let's differentiate y. What do we have? When you differentiate y, you have the y, the x equals to. Now I have product here. At this point, I will have, if I have to differentiate y, I will say, I will hold s constant and differentiate v. Right. Plus, because they are both variable at that point, I will hold v and differentiate x. These two are product of they are variables, so that's why we are differentiating them. So at this point, I have x, the v, the x, plus this one cancel this, right? You have v. So it simply means that my dy dx is equals to this. My dy ds is equals to this. Any question? Now, we are just doing this just for representation. Don't forget, we are just representing our value. Let's look at the example. By the time we get to example, you will understand better how and what are the things, why are we doing this? Remember, we said method, homogeneous method. So let's look at the example. Example 1 says, are we there, please? Can I proceed?
Yes, sir. Proceed.
Okay. Let's look at the example 1. It says the y, the x equals to x squared plus y squared over xy. X squared plus y squared over xy. So for us to solve this, what do we have? What comes to your mind when you have something like this, please? Be sincere to yourself. Some of your questions might not be able to tell you that using homogeneous method. But because you are in the class, you can see that you need to use the homogeneous method. Right. So now let's look at this. Solution. The first step you need to do is just to eliminate. How do you reduce down? Everything you need is this. Let's go back to this. The only way you'll be working towards this place. How do I get y over x? Or how do I get x over y? Or how do I get this? So now let's look at it. Divide through by, because the first element there says s squared. I need to reduce that s squared because there's no provision for s squared in my representation. I only have y. Do you agree with me?
Yes, sir.
So I only have y, I have v. I can't get v without, I can only get v by x, y over x. So I need to eliminate x squared. I will now say step 1, divide both sides. Divide. Divide all term. Let's use all term. Divide all term by s squared. By x squared. So I have the y, the x, equals to x squared divided by s squared. Please mute yourself. Your background is making noise. Have you seen it? So I will have what? This one will turn to 1 plus, you agree with me if I said y over x all squared divided by, this will go, I will have y over x. Do we all agree with me? That is,
Yes.
1x
Yes, sir.
will go, this one will go. So you have it. I know my y over x, I know the y, the x already. So I can go ahead and substitute the y, the x. But before then, I can say, let's write it that the y, the x is equals to 1 plus y over x all squared divided by y over x, which is the same thing as, okay, let's leave it this way. But don't forget, recall, said, let's, our step 2 now, we said let y equals to vx, right? Then v equals to y over x, just to reduce them. and the y dx equals to s dv dx plus v. Remember, we have the representation up before. I don't need to prove all those jargons to you. Nobody will ask you that. If you want it, if you want the proof, you can check books. You get some of those books, some of those proof. So now let's represent them. Now we have it. The y dx is here. Let's substitute this one. The y, I can call this one equation 1. Then equation 1 becomes, let's look at it. S dv ds plus v. That is the y dx equals to 1 plus, what is y over x? Do we agree?
Sorry, sir. Can you come
Yes, sir.
over?
Yes, sir.
Why you said?
Can you like come over again? I didn't get to that part. Maybe I got distracted.
Oh, you need to be here. So from where? Okay, look at this. You know equation 1. What is your equation 1? Can you see equation 1, please?
Yes, sir. 1 plus 2 y over x open bracket
All square.
All square. Just say all
All
square.
all square. Yeah.
All square over y over x. And I know my y over x is being represented by, this is my y, this is my representation here. Are you getting it now? So
Yes, sir.
anywhere I see y, I will substitute this. Anywhere I see v, anywhere I see y over x, I will represent them with v. Anywhere I see the y dx, I will represent them with this. So that's why I now said equation 1 becomes what? So the y dx turns to x dv dx. Remember when we differentiated this one? So we substitute it here. Then I have 1. 1 is here. I have y over x. Y over x is the same thing as what? V. Because it's squared, it turns to v squared. Right. And I have over v is here. Any other question?
No, sir. You can proceed, sir.
Okay, thank you. So we can also play some mathematical game here by saying x dv dx plus v is the same thing as 1 all over v plus v squared over v. Do you agree with me? It's like you have LCM and you put everything under LCM.
Yeah, that's correct, sir.
Yes.
Yes, sir.
So we have it to be, this one we go with this. So we have x dv dx plus v equals to 1 all over v plus v. Right. So what do we need to do? Take this one v to the other side. Take, it's a positive. When it crosses to the other side, it turns to negative, right? So you have it to be x dv dx equals to, take this one to the other side, 1 all over v plus v minus v, because this one is moving to the other side. So it's not multiply anything because of addition we are dealing with at that point. So at the end of the day, we are left with what? S dv dx equals to 1 all over v.
I'm going to cross multiply, sir.
Are you getting it?
Yes.
Now, we need to do something. Guys, please mute yourself. Otherwise, I will remove you from the platform. It's very easy for me. Okay, the next thing is we need to do a separable variable here so that all v will go to v, all x will go to x. How do we do that? We can start by saying s dv equals to 1 all over v dx. Right. So, and I need to multiply both sides by v. If you multiply through by v. So if you multiply through by v, what do I have? I have v s dv equals to v in bracket 1 all over v dx. So this will go with this. That's the SS. So at the end of the day, okay, sorry. This go with this, so you understand it when you are watching the video again. So here we have Vx, the V equals to the X. So we need to divide through by what? X also. When you divide through by X, what do you have? Divided by X, divided by X. This S also will cancel. So at the end of the day, we have what? We have V dx, V dv, sorry. We have V dv equals to 1 all over x dx. So all we need to do is just to integrate both sides. Integrate both sides. So when you integrate both sides, what do you have? Integral of v dv equals to integral of 1 all over x dv dx. So when you integrate v dv, what do we have here? You have v squared over 2, right?
Yes, sir.
Equals to, when you integrate 1 over x, you have what?
Ln S.
Absolute value of ln x plus c. So in this case now, all we need to do is just to say 1 is the same thing as 1 all over 2 v squared equals to ln x plus c. But if you multiply through by 2, what do you have? You have v squared equals to 2 ln s plus 2c. 2c is still c, right? Remember, like I always tell you, constant is still constant, no matter where you are bringing it from. So we are still going to be 2 equals to 2 ln absolute value of plus c. Now, we need ordinary v. So you take square root of both sides. When you take square root of both sides, you have v equals to plus or minus, because I'm taking the square root based on our knowledge of quadratic. You have 2 ln x plus c. Now, what is our v initially? What do we use to represent v initially? Hello?
Yes,
Your
sir.
v is equals to what from the beginning?
V is equal to y over x, I think.
And you substitute in that, y over x equals to plus or minus square root of 2 ln x plus c. So at the end of the day, what do I need? I need my y. So I multiply both sides by what? X. So when you multiply both sides by X, you have Y equals to X plus or minus. No, you take it to the other side. Remember, this plus or minus will come here. Square root of 2 lane X plus C. Right. So what do you have? That's your final answer. Any question? Any question, please? Silence means no question.
Sir,
Yes.
how can we know that we are going to apply homogeneous method to your question?
So if we get to a stage, don't worry, by the time we get to a point, I will. How many of us have seen the past question before? The number one, the nature of the equation will determine. If you've seen your past question, probably next class I will try and share my screen. I'll look for 1 or 2 questions and then I will share with you guys. Then you yourself will know that this is homogeneous. And the way they will ask the question, you will see it. Right. So let's look at this. Another question. Then your course material, you can also look into your course material. You will see the way they put some of those questions there. Then that will give you the understanding how they ask questions and you familiarize yourself with it. Then you'll be able to solve as many problems as possible. Right. So let's look at this. 2x dy equals to x plus y dx. 2x dy, x plus y dx. Abigail, are you still there?
I am, sir.
Oh, okay. So let me quickly say this. And it will help every one of you guys. Let me stop sharing. Where is Abigail? Can you on your camera? Is it possible? So, as I was saying, if you look at this particular work, you discover that the question that I gave you now says what? It said 2x dy equals to x plus y. 2x dy equals to x plus y. So how do we solve it? Anybody with an idea? What do we do first? We are waiting for you. I need someone to come up with an idea that can help us. Okay, let's go on. There are different questions, different methods, solution now. Now, in this case now, we have, remember that we have, what is our dy? What it said, that's the first thing you do. Let y equals to what? Vx. Then remember we have the y dx to be equals to what? Somebody to say it. The y dx is equals to what? Okay, we will be
Is
waiting.
it x? Is it x dv dx plus v?
X
dv over dx plus v?
Yes, that's I gave you. Now, but if you look at this, you only have this, dy. Right. I can now go ahead and make the y out of this. If I want to make the y out of this one, that means I will multiply both sides by what? The x. Multiply both sides by the x, what do I have? If I multiply both sides by the x, I have what? The y equals to x dv plus v dx. Right. So anywhere I see the y, I will substitute this equation there. Equation star. And I know my y to be v over x, vx rather. So let's call this one equation 1. Equation 1 becomes two x in brackets s dv plus v dx equals to x plus what is y? Y equals to vx dx. Right. Are we all together?
Yes, sir.
Okay. So the next thing is, I said 2x x dv plus what?
EDS.
VDS. Which is the same thing as x is common here. I can factorize 1x out by saying I factorize the x out by saying 1 plus v the x. So this will go with this. So if that one is go, what do I have? So I will go to have what? Let's open the brackets. I'm going to have 2x dv plus 2v dx equals to 1. 1 will be 1 multiplied by the x will be the x plus v dx. I can collect the like terms. Something is common. I can take them together. So I can take the x to the other the x. So you agree with me that these and these are common, right? They are the same. Do you agree?
Yes.
Only that one has 2, one has v. 1. So if I match the two together, what do I have?
That should be V.
Yes. So it's going to be 2x dv plus this. If I remove one of these from here, it will give me v dx equals to the x, because everything that one will have moved, will have. Okay, it's not clear to you. Okay, let's do it this way. Take this one back here, minus v dx equals to the x. So you can take this one, it will now be 2x dv plus v dx equals to the x. So what do I have at the end of the day? Something is still common. What is it? I can take this one back to the x, because this is dv. I will just say 2x dv equals to the x minus v dx. So I have 2x dv equals to 1 minus v dx. Right. So I need to do what we call separable variable. The method that we learned last week, we need it now to implement it. So for us to divide both sides, what do I need? I need to divide. I need v to go to v. I need x to go to x. So it simply means I'm going to say that v is here, s is here. So how do I do? Divide both sides by 2x 1 minus v. Because I need this, I need this. So 2x and minus v. So I would now say 2x v will be 2x 1 minus v equals to 1 minus v dx over 2x in bracket 1 minus v. So this go with this. Then 2x go with 2x. At the end of the day, everything has been separated, and we have dv over 1 minus v, which is equals to the x over 2x. Any question on that? At this point,
Clear, sir.
it's clear. At this point, we need to integrate both sides. Integrate. Both sides. So if for us to integrate both sides, what do we have? We have integrate of dv into 1 minus v equals to integration of the x over 2x. So I have this one to be 1 all over 1 minus v dv equals to 1 all over 2 integral of 1 all over x dx. So that you simplify them, because these two can be separated, they are constant. So what do I have at the end of the day? So if I want to, for us to differentiate, to integrate this one, what do I have? If you integrate this one, you have what? Minus ln 1 all over v equals to 1 all over 2 ln x plus c. Why is it minus? If this one is positive, this one would be positive. But because this one is this place, if this place, the one I circle is positive, it won't affect this one. It will affect this one to be positive, but this is negative. Go and check your integration and discover that right. Please mute yourself when you are not talking. Thank you. So at the end of the day, what do we have? Remember the law that says n log x is the same thing as log s raised to power n. Remember this? So the same thing will happen here. So we are going to have, this is more or less minus 1. So we have ln 1 minus v raised to power minus 1 equals to ln s raised to power 1 over 2. Right. Plus c. Because ln c will also be c. There's nothing you can do into it. But the major thing we can always do in this case is remember that at this point, if you call this place, if we just call this one ln c, what do we have? If you call it ln c, remember the laws that says that ln a plus b is the same thing as, sorry, ln a plus ln b is the same thing as ln ab, this particular law. So it's the same. So we have it to be ln 1 minus v raised to power minus equals to, now what this one means is when you find the square root of the both sides, at this particular side, we have ln square root x. That's the meaning of this. But this particular one also, but don't forget you have c. You have ln c. It's still the same. It's still constant. Always refer it as constant. Don't be disturbed by lane C or C. It's still a constant. But why we share the link with them so that this law can occur to them because of this positive. And don't forget, this particular one is the same thing as link 1 all over 1 minus V, the way it is. Now, I can now mark this one together by saying lane is common, C is here, root S, based on this law that says lane A plus lane B is equals to lane AB. So lane's square root S plus lane C is the same thing as lane C square root S. So take note of that. By the end of the day, you discover that the lane will go with the lane, and we are up with our value to be C equals to S, CS. Then what is our X? What is our Y from the day one? We can substitute it back to it. We know V to be what? What is your V? Anybody? Our V is equals to what, please?
Oh, yeah.
Y over X, right?
Yes, sir.
Equals to C square root of X. When you rationalize this one, what do you have? You have it to be what? S over S plus S minus Y equals to C square root of X. I can multiply both sides by, remember, I'm looking for my value. Let's see how we can get it out of this place. So it's the same thing as if you multiply both sides by what? X minus Y. S minus Y equals to so this will go with this. So you have X to be equals to C square root of X into X minus Y. So we are trying to take what we call, we need to know which one, what is our X in particular. We still have it within. So what we need to do at this point is just to take the square of both sides. Let's take the square of both sides and see what will happen. Take because we are trying to remove that square root. So if we take square of both sides, we have X squared equals to C square root of X into X minus Y all squared. So I can square each of them. I can say S squared equals to C squared square root of X all squared and X minus Y all squared. Right. So if I do that, it simply means this square root will go with this. So I have my X back. So I can have X squared equals to C squared X square in brackets X minus Y all squared. So if I divide both sides by my X, what do I have? I have X squared over X equals to C squared X into X minus Y all squared. Everything divided by X. This go with this. So at the end of the day, I have this one go with this. I have X equals to C squared into x minus y all squared. Don't say they will not ask us. It's too long. They will ask you. Don't be too sure because I know they will ask. So
81.
it is what? So at the end of the day, we can say the modulus of x is equals to c into, because whether c square or c cube is still c. That's what I told you the other time. X minus what? Y all squared. That's your homogeneous equation for this one. Any question? Because of our time, let's quickly look at.
The last one should be okay.
Yeah, that's the
C.
final answer. Let's quickly look at this this question. You see, I'm teaching us different way of setting questions, and so that I want you to grab that. Who is this guy? Okay, so let's look at this. We have y prime equals to xy over x squared minus y squared. Remember, y prime is what? The y, the x, equals to xy all over x squared minus y squared. Are you getting it? Please, what topic are we treating? I joined the class list network. Okay, Alexandra, are you there now?
Yes, sir.
Okay, it's homogeneous equation, homogeneous method under chapter 3. That's what we are treating. So,
All right.
but you can watch the video later and it will help you to be able.
All right. Thank
You.
So where do I get you? Is it from the school portal or WhatsApp group?
Which of them?
The video, the recorded video.
Do you access your course page?
Yes, sir.
Have you seen any of the video on MTH?
Yes. Live session. Yes, I do see that.
That's where you will see it.
All right, sir. Thank
You
you.
can also see it on your WhatsApp group.
All right. Thank you, sir.
You're welcome. Okay, let's continue. So in this case now, we can say that solution. How do we resolve this? We know the y, the x. I can cross multiply and say, let's the x, I can cross multiply from here. If I cross multiply from here, I will have x squared minus y squared, or the y, equals xy dx. Do you agree with me? This is what I did. I just said this multiplied by this and this multiplied by this. Do you agree? Okay. Silence means we agree. So we can call equation, we can call the entire one equation star or equation 1. Let's say equation 1. Now, from here, what do we do? Remember that our dy is the same thing as s dv plus v dx. We did that the other time. So I can substitute it there. So what do we have here? We can arrange this one. And don't forget, your y is the same thing as vx. So if I change the direction, I can say that I have x into vx dx equals to s squared, I'm talking this one, minus v squared s squared. And the y is the same thing as s dv plus v dx. So let's open the brackets one after the other. X multiplied by x, we have x squared v dx equals to, we can open the bracket of this one. If you open the bracket of this one, but before then, something is common here. S squared is common. I copied it. 1 minus v squared is here. Then I said x dv plus v dx. This go with this. So it make our work easier. We have v dx equals to 1 minus v squared. So at the end of the day, you have 1 minus v squared, or we can open the brackets of 1 minus v. Let's open the brackets here. Let me see. We have 1 minus 1 multiplied by xv, x dv. We have x dv. 1 multiplied by this, we have plus v dx. Minus 1 multiplied by v squared, minus v square x dv, minus times minus, we have minus v cubed dx. So you discover that some things we cross out. Like this, we go with this. So I have what? I have, we can say we have 1, right? Or just say we have v, take this one to the other side, we have v cubed dx equals to x dv minus v squared s dv. Any question? So in this case now, something else so common to both sides, to this side, we have v cubed dx equals to, x is common here. I factorize my x out. I say 1 minus v squared dv. Separable variable now. How do we separate the variable here? Separable variable, we divide both sides by v cubed x. If I divide both sides by v cubed x, what do I have? I will have v cubed dx over v cubed x equals to x in brackets 1 minus v squared dv over v cubed x. So what do we have here? These go with this, right? So if, and s go with x. So we have the x over x equals to 1 minus v, 1 minus v squared over v cubed dv. So you can see that each of them now have their own shape. But we cannot integrate directly, but let's look at it critically. How do we do that? So if I said integrate both sides, it's still the same thing as integrate both sides, 1 over x dx equals, we still need to simplify this one by saying integral, if I said integral of this, 1 minus v squared over v cubed dv, you will see what will happen. We can separate this one by saying integral of 1 all over x dv, the x equals to integral of 1 all over v cube, right, dv, minus integral of v, you see where you said v squared over v cube. Remember, this will remain 1. It will be 1 all over v. That's what will happen. So this one will be, divide each of them by v cube. That's what I did. So it's going to be 1 all over v dv. So here what we have ln x equals to what? Ln x equals to, or it's going to be ln x modulus of ln x because of the nature of the integral. So what do we have here? So it's the same thing as when you have v raised to power minus 3. That is inverse of it, dv equals to minus, what do we have here? Ln absolute value of v, everything plus c. So if I want to integrate this one alone, what do I have? Remember, the integration of this will be, it's the same thing as v minus 3 plus 1 over minus 3 plus 1. So which is going to be what? V minus 2 over minus 2, which is the same thing as minus 1 all over 2v squared. So this is the solution for this. So you can substitute it back here. So we are going to add everything to be integral of this equals to integral of, equals to, let me just substitute the answer, not integral again. I've done the integration separate. So it's going to be minus 1 all over 2v squared minus ln v plus c. Now, we have all our v here. What do we need? We need to substitute what is v. Everything must be in x and y again. V is equals to y over x, which implies y is equals to vx. So let's substitute where we see v now. What do we have? We have ln x equals to minus 1 all over 2 into y over v, y over x all squared, minus ln absolute value of y over x plus c. So what's the final answer in this case? Who can tell us the final answer now? We are almost there. So it's going to be ln x equals to, if you find this one, what do you have in this? You have the same thing as minus, it's the same thing as minus 1 in bracket x squared all over 2y squared minus ln y minus ln absolute of x. Remember, according to law of indices, when you have division, it's the same thing as negative. So you have to do this. Open the bracket, what do you have? Ln x equals to minus x squared all over 2y squared minus ln absolute value of y plus ln absolute of x, everything plus c. This will go with this automatically because of the nature. When you take it to the other side, this is what we have. So we have this one, we're almost there. It says 0 equals to minus x squared over 2y squared minus ln y, everything plus c. So I can take my ln y to the other side. What do we have? If I take ln y, I have y equals
Excuse me, sir.
y.
I didn't get how we've gotten the ln x equals to minus x squared all over 2y squared.
Okay. Do you agree with this side? Do you agree
Yes,
with
sir.
this?
Yes.
So if you agree with this, it's the same thing as you have minus y all over 2y squared over x squared. Do you agree?
Okay. Okay.
So by the time you take this one, division or division, this one will automatically come up here. So
Okay. Okay.
it's more or less
Go
like,
ahead.
okay. So when you take inverse of that, it will come up. Thank you for that. Okay, guys. So we have minus x squared over 2y squared, right? Plus c. So the question is, how do we eliminate the ln from this y so that we can get our ordinary value? So we take exponential of both sides. The exponent of both sides, you have this to be equals to exponent minus s squared over 2y squared plus c. That's what we did. So at the end of the day, the exponential will cancel the ln. You have y equals to exponent minus x squared, y squared, 2y squared rather, dot exponent c. You remember positive dot means multiplication in when it comes to plus in exponential. So at the end of the day, our y is equal to exponential of minus s squared over 2y squared dot c. C is exponential of c is still c. So you have y equals to c exponential minus of this over 2y squared. Any question? Any question? No question. Okay, I'll give you some questions to solve by yourself. Take your time and do it. Never can tell. Should I give us? Or you are not interested?
Give us a let's try.
Okay, let's do this assignment. Just take your time and do it. Number 1 says y prime equals to 2x exponential minus y over x plus y all over x. Let's say we have, they now give us boundary condition, initial value. Initial value you are given is just for you to find your C at the end of the day. So you don't need to be afraid that, but the man did not teach us this. It's the same thing. When you get your C, substitute 1 and Z. And what is 1? 1 is equal to your x and y. Y is equal to 0. That's all. Then 2. I'll give you the 2 one. Solve the y, the x equals to 2y squared plus 3xy over x squared. We'll solve something similar. So you can solve this too. Take your time and solve it. Then if we solve it, you can send it to my email. I will appreciate it. Just take your picture. You can send it to my WhatsApp, either of the two, anyone. Just make sure you solve it. Any question, please?
Okay, sir.
Any question? Can I stop sharing, please?